Good afternoon, ladies and gentlemen. My name is Omar Abu Gharbiya, industrial engineering student. I'm taking this semester the course of manufacturing processes alongside my colleagues Abdul Rahman Al Ishtawi, Kareem Al Saadi, and Bakr Al Farhan. Part of this semester's syllabus is to come up with a presentation and record it and post it on YouTube about material that we use in our a simple material that we use in our daily lives. We have made our presentation about radiators. What is a radiator? What is its purpose? And where is it used? A radiator is the key component of the engine's cooling system. Its main role is to disperse a mix of antifreeze and water. Antifreeze is a substance, it's a cooling substance, it's liquid, and water through its fins, which releases some of the engine's heat while taking in cool air before continuing to pass the rest of the engine. Within the radiator itself, within the radiator itself, it has three main parts. The first part, the outlet and inlet of the tanks. The second part is the core, which is in between. And the third part is the pressure cap. Each of these three parts plays its own role within the radiator, own crucial role. The main role of a radiator hose is to connect the engine to the radiator and allow the coolant to run through the respective tank. The inlet tank is in charge of guiding the hot coolant from the engine to the radiator to cool down. Then it circles back out the engine through the outlet tank. After the hot coolant comes in, it circulates through a huge metal plate that contains multiple rows of thin metal fins that help cool down the incoming hot coolant called the core. It has a large surface area which helps the cooling down process. Then it is returned to the engine through the outlet tank once the coolant is at appropriate temperature as to not to let the engine overheat. While the coolant undergoes such a process, there is also the pressure or radiator cap, pressure cap or radiator cap. The role is to tightly secure and seal off the cooling system to make sure it stays pressurized till a certain point. Once it reaches that point, it will release the pressure, and obviously without the pressure cap, the coolant might overheat and cause an overspill, thus causing the radiator to work inefficiently. So it has a crucial role keeping the pressure inside of the radiator. The types and structure of the radiator components. The tube and fin, it's common, simple heat dissipation. Plate fin is compact, ideal for HVAC, heat ventilation and air conditioning. Cross flow, efficient horizontal cooling. Downflow, simpler vertical design. Single pass, low pressure, simple design. Multi-pass, better heat transfer, better heat transfer, multiple loops. And it can consist of higher pressure. The structure. The core is the main heat exchanger within tubes and fins. The tanks store the coolant, and the tubes made of aluminum or copper dissipate heat. And the brackets and the fittings secure and connect components together. Now we move on to my colleague Abdul Rahman. Abdul Rahman, you can take it from here.
Guys, can someone just close the mic so we can speak? Yeah, thanks. So this slide lists the main materials and components used in the construction and function of the radiator system. As you see, I have 14 parts from the materials used in the radiator. Number one, the auxiliary radiator, the mount bracket screw, the drain plug, the thermostat O-ring, the water outlet, the battery tray bolt, the tank assembly radiator overflow, the battery tripod, the radiator screw cup, and the coolant hose, the inlet duct seal, and the radiator coolant hose C slip. Together, these components ensure the radiator can effectively manage engine temperature, prevent uh, overheating, and maintain proper engine function. Each part plays a specific role in ensuring the durability, safety, and performance of the vehicle's cooling system. Now I'm gonna move to the next slide. What are radiator parts? Automobile radiator are made up of two heater tanks connected by core with many tunnels, giving them a large. Uh, Guys, just it's before this slide, not this. Yeah, yeah, okay. Uh, Giving them a large surface area for their volume. This core is often made up of stacked layers of material sheets that have been pressed into channels and then soldered or braced together. Radiators have been built from brass or copper cord soldered to brass headers for many years. Plastics headers and aluminum cores are used in modern radiators to save money and weight. This structure is more difficult to repair than typical materials. Next slide. Antifreeze mixture have three parts. I'm sorry, the pressure cup have three parts. The maintains cooling system pressure and 15 psi, prevents overheating by releasing excess coolant pressure, and critical for safe and effective engine cooling. Anti-freezing mixture prevents freezing damage, stable, non-corrosive, easily mixed with the water, and protects engine even in extreme cold conditions.
Uh, and now I will begin about reserve tanks. It's as the current heat up, it's expand increasing pressure within the sealed cooling system. This international and helps raise the boiling point for the coolant with ethane glycol coolant can safely reach temperature over 250 Fahrenheit. The radiator pressure cap maintains system pressure when pressure exceeds a set limit. A spring-loaded valve in the cap open to safely release the excess, protecting the system from the damage. And now the reserve tanks, its automobile radiator consists of the metal or plastic tanks connected by a core of narrow passage, which maximized heat transfer through a large surface area. Traditionally, radiators were made with a brass or copper cores and soldered brass heads. Modern design use aluminum cores with plastic caps, which reduce cost and weight but are harder to repair. All methods included a honeycomb radiator, hexagonal and pipes stuck in soldered, forming strong but complex structures. Coil tube design, simpler but less efficient in heat dissipation. And now basic principle of a car radiator. Coolant plays a virtual role in transferring heat from the engine via the radiator, a heat exchanger cooled by air, while some engineers can use large volumes of direct water. Regular water can carry debris and corrosive salt that damage the engine. To solve this engine coolant, a mix of water, antifreeze, and rust inhibitors is used to provide better thermal stability and prevents corrosion. Common coolant include the ethylene, glycerin, propylene, and glycerin or their mixtures, offering effective and safe cooling. And now we will move on to my friend Bakr.
Hello, I will talk about liquid and air oil cooling. To keep essential engine parts and the oil of appropriate temperature, most air-cooled engines employ some liquid oil cooling. Most liquid-cooled engines employ some air cooling. With air cooling, the combustion chamber during the intake stroke. Wankel engines are an exception, as some portions of the combustion chamber are never cooled by intake, necessitating more effort from proper operation. Cooling is influenced by the qualities of the coolant, water, oil, or air. When comparing water and oil as a coolant, for example, 1 gram of oil can absorb around 55% of the heat for the same temperature rise. This is known as the specific heat capacity. Requires for air cooling. As oil has a density of around 90% that of water, a given amount of oil can only absorb about 50% of the energy that the same volume of water can. Water has a thermal conductivity of around 4 times that of oil, which can help the heat transmission. Oil viscosity can be 10 times that of water, increasing the energy required to pump oil for cooling and lowering the engine's net power output. When comparing air and water, the air has a lot lower heat capacity per gram and per volume, 4,000 and a tenth of conductivity, but it also has much lower viscosity, approximately 200 times lower, 17.4 106 Pa for air versus 8.94 104 Pa for water. Requirements for air cooling. Continuing the computation from the previous two paragraphs, air cooling requires 10 times the surface area, which necessitate the fans, and air requires 2,000 times the flow velocity, necessitating 10 times the power of restricting water pump. Moving heat from the cylinder to a wide surface area for air cooling can pose challenges, such as creating the geometrics required for efficient heat transfer and providing enough room for a big volume of air to flow freely. After that, we will move again to my friend Omar to do the conclusion. Thank you.
Hello again, everyone. To conclude, we have 3 points to discuss. The radiators vital for engine thermal management, which means that they are essential for managing engine temperature effectively. The radiator plays a crucial role in engine thermal management by preventing overheating and ensuring optimal performance. The production involves precise assembly and quality materials. In assembly and the high use of high quality materials, their production demands high precision, careful assembly, and the use of durable, high quality materials to meet safety and performance standards. Advances focus on efficiency, lightweight, and durability. Ongoing advancements in radiator technology generally focus on improving heat transfer, efficiency, reducing weight to enhance fuel economy, and also increasing overall durability for longer service life. And that is our presentation about radiators. Hopefully, we've met all the requirements needed. Thank you for listening.